Hello everyone, welcome to a GIS statistics lecture video. In this video I want to talk about how we actually implement some of these point pattern analyses in R. The first one that I want to talk about is going to be the spatial KDE, which is the kernel density estimator, how we implement that in R. So the first thing we're going to need to do is make sure that we have our packages that we need. So the packages that we're going to want are GIS tools for the data, we're going to want tmap in order to make the map. We're going to want the SF or simple features package because it assumes that the spatial KDE package assumes that the data is in an SF data format. Okay, so I do believe that's everything we're going to need. So we've got all three of those packages. Again, GIS tools for the data set, tmap for being able to map things, SF. Oh, we do need one more. We need the spatial KDE. So if you don't already have this one installed, install packages or however you get it. You want spatial KDE, and then you want to make sure that it's available in your R session. Okay, so how do we actually go about doing this? So I'm going to use a one of the New Haven data sets. I'm going to use this places data set. Actually, let's use breach. We'll use the breach data set. So we'll call breach equals breach. So I just want to really quickly check and make sure that breach is what we think it is. Just make sure that it is a spatial points, yes. Make sure that it has a projection, yes. Okay. So we're good there. Now what I want to do, the first thing I want to do is I want to map the data. And I'm going to do that, just quickly make a tmap, tm equals tm underscore shape. And we're going to pass in breach. And then we're going to say plus tm underscore dots. I'm going to call tm. Okay. I'm just going to do that down here really quick so we can use the plotting window. Okay. Let's actually go ahead and add one more. Let's add the blocks, just to give ourselves a little bit of context. Borders. Let's do that. That way we have a little bit of context. Okay, so this is the data set that we're looking at. Now the next thing that we want to do is just quickly add in our KDE. So the way that the KDE works is the spatial KDE. Actually, let's do this. Let's bring up the help menu for spatial KDE, colon, and we want the kernel density estimator or the KDE function. Okay, so what does this take in? As parameters, it takes in points. These are the points. These are the data set that you're interested in estimating. It takes in a bandwidth. This is that bandwidth that we've talked about in the videos, in lecture videos, that is that distance away from the point that we're going to use to estimate. And then kernel, we're going to keep as quatric. Again, you can use different kernels, but quatric is the default that we're going to stick with in most of these cases. And then we have this idea of grid or cell size. So if we scroll down, grid is an SF data frame. So this would allow us to pass in a data set that we want to populate. Cell size would internally create a new internal data structure. So we're going to be using this grid here. We're going to pass in a new raster. So we're going to create a raster. I'm going to call it RS template. And the spatial KDE package has a function called create raster, which if we do spatial KDE create raster, right, you'll see that it requires a geometry, and this is going to be basically the boundary that we want to create the raster for. It's going to create, and then cell size, which is going to determine the size of the cells in the raster. So the first thing we need to do is we need to pass in, before we do any of this, the big thing here is this SF, right? We need the data to be in an SF data format. So in order to do that, we need to actually convert our breaches to an SF data format. And we do that with a function from the SF package. So we're going to call this breach SF. And we do that with the function SF. We do that with the function st as SF. This is going to convert the SP object that breaches currently into an SF object. So we do that. So if we run this, we now have an SF version called breach_SF. Now what we can do is we can create our raster template, which we're going to call RS template or RS temp. Right. And now we're going to call that, again, we're going to use a function from the spatial KDE package, create raster. So again, it requires two parameters, geometry. This is going to be the SF object that we just created. So this is going to be that breach_SF. Then it requires a cell size. So in this case, it's kind of optional. The smaller the cell size you go, you're going to end up having increased computational time. So we're just going to go with something like 100. So cell size in this case is going to be based on the units of the projection. So in this case, our cell size is going to be 100 meters. So if we run that, you don't need to worry about this this warning here. It doesn't actually do it doesn't impact the process here. The next thing we're going to do is we're going to actually run the kernel density estimate. So from spatial KDE, we're going to run the KDE function, which again requires points. This is the data set that we are trying to use, which we need to use that simple features or the SF data format. The next parameter that it requires is that bandwidth. Now bandwidth, again, is going to sort of be up to you to figure out what you want to use. We're just going to go with something. I don't actually have a good estimate, so we're just going to go with 100 just to sort of prove that the code will work. Again, you'd want to spend some time considering this value, a lot more time than I have. Then the final parameter you need is this grid parameter, and this is going to specify the locations that you're actually going to estimate for. And this takes in as the option this empty raster that we made, right? This create raster, that's what's going to go in here. So what this is going to do is it's going to go in, it's going to, for each cell in the raster template, it's going to use a bandwidth of 100 and the points from our simple features object to estimate the number of points that are going to occur inside of that grid cell. So if we run this, right, it's telling me that I've made a large image, and again, that comes back to this cell size here. So if you go really small in your cell size, this could take a while. So now, if we type in var, what do we have? So because we fed it in a raster as grid, it gave us back that raster. So we have a raster layer. So this is a raster where the values in the raster are the number of expected points in that grid cell. So now what we can do is we can take those results and we can actually add them to a T-map. So what I'm going to do is I'm going to copy our T-map from before, and on the very bottom, I'm going to add in a TM underscore shape. I'm going to add in the var, the raster that we just made, and I'm going to add in a TM underscore raster. And then just so that we can see these a little bit better, I'm going to make the dots a little bit bigger. Make them size 1. And if I do that, so we can use the plot over here. Oh, actually, I think I made the dots a little too big. We can't actually see what's going on underneath it. Let's go 0.25. Let's do that instead. I think I might have made the bandwidth too small to actually see anything going on here. Let's increase the size of the bandwidth a little bit. There we go. Now we can start to actually see some of the differences. My bandwidth that I chose arbitrarily was way too small. So you can see here that we've got some areas where we've estimated the density for. So that's how the spatial KDE function works. And that's what all the different parameters mean. And that's how you would set this up. So hopefully that makes sense. If you have any questions, please reach out. Thank you.